Hello, everybody. This is a CER writing guide. So it's kind of a tutorial on how to write a proper CER for the CER test we just took. And Physical Science 2, that's what the PS2 stands for, Learning Set 2. So it's the one that we gave, which kind of connects 5, 6 lessons, 5, 6, and 7. This will not be an answer key in the sense that we're just going to put up the answers and you can just pause the video, copy them down. You're not really learning that way. So it's going to be more of a writing guide, how to get you to the point where you can write a good, solid CER. I'm confident that if you persevere and go through the whole video and you maybe rewind a couple spots and listen, I'm pretty confident you will be able to score proficient in all three parts of the test. So again, when we're talking about a CER, we're talking about looking at the evidence. And I always like to talk about the evidence first because you can't make a claim without looking at the evidence. So by looking at the evidence, this is what you know. Can you make a claim? Can you answer a question? And I'll show you what the claim is for this CER. And the reasoning is, why does your evidence support your claim? How is it connected? And all this together is called a scientific explanation. So here was the premise, or here was the question you're supposed to answer in your claim. Which energy conversion diagram on the left, so you're going to have to pick between one of these four. Which energy conversion diagram on the left, numbers 1 through 4, is the best example of a tennis ball at position 3? So sometimes people get these confused and they'll say, well, am I supposed to pick one of these? No. So here's the tennis ball at position 3. It's by the arrows, you can see it's dropping. Which one of these four would best represent the tennis ball at this spot right here? Now, we are not factoring in thermal energy at this point. I know we've talked about it in class, but I don't want you to look at this and say, well, none of them have thermal energy. We're not going to factor thermal energy into it at this point. So you're going to have to pick one of those. Now, before we do the claims, I really like to look at the scientific principles. A lot of times the scientific principles help us with finding the correct claim. And a lot of times, and what you're going to see what I'm going to do today is I'm actually going to look at the evidence after I look at the scientific principles, then I'm going to go ahead and make the claim. So let's read through these. You can see that there are 9 of them. So, any moving object has kinetic energy. Is that true? Yeah. And one of the most common mistakes people make when they're doing this is they'll say, oh, that's true, so it must be the one. No, all these scientific principles are true. So any moving object has kinetic energy. So does 3 have kinetic energy? Yes. Does 2? Yes. Does 4? Yes. So this number 1 really doesn't help us narrow it down to figure out if one of these is here, because this one's got Ke, this one's got Ke. So while it's true, it really doesn't help us narrow down the correct scientific principle. Let's look at number 2. An object's kinetic energy increases as its speed and or its mass increases. So when we look at these arrows, this means that Ke is going down, Ge is going up. Ke is going up, Ge is going down. And then these are the same, they're just kind of crisscross, but they also include elastic energy. So let's read this again. An object's kinetic energy increases as its speed and or its mass increases. So if this is a falling object, what's happening to the speed? You're probably going to say, well, it's getting faster as it drops. And you're absolutely right. So let me ask you this. If the speed is increasing, what's going to happen to the Ke? It's going to be going up. So now all of a sudden we can narrow a couple of these down. So if Ke here is going up, it could be this one, but it could also be this one. Ke is going up. So number 2 is a really good scientific principle. It helps us narrow it down between these two, and it helps us eliminate a couple. So number 1 was, it's true, but it really didn't help distinguish between any of these. But number 2 does. It narrowed it down between those two. Scientific principle number 3, any elevated object has Ge. Again, this one has Ge, this one has Ge, this one has Ge, this one has Ge. Now, if this is touching the ground, it doesn't have any Ge. So 3 is a lot like 1. Yeah, these all have GE, but they all have GE. It doesn't narrow it down at all. So it's true, but it doesn't narrow it down. So 3 is not a good one to use. How about 4? An object's gravitational energy, or GE, increases as its elevation and or its mass increases. So it's a lot like 2. Let's look. At position 3, we know it's dropped from 1 to 2 to 3. So it's decreasing in elevation. So if an object decreases in elevation, so it's the opposite of this. Here it says increase, but if it decreases in elevation, what's going to happen to the GE? The mass stays the same. GE goes down. So now all of a sudden, yeah, it's going to be one of these two, where here the KE is going up, there the GE is going down. So both 2 and 4 help us. So we've eliminated 1 and 4. Those are not possible answers. So we narrowed it down just by reading the scientific principles. 5, energy can be converted / transformed from one type to another. That's true, but that helps us absolutely not. It doesn't help us with this. It's true, but it doesn't tell us what's going on. It doesn't narrow this down at all. So 5 is not something we can use. 6, any deformed rigid object has elastic energy if it can return to its original shape. Can we use that one? So is number 1 deformed? Is position 2 deformed? We only need to be concerned about position 3. Is it deformed yet? No, because it's still in the air. It won't be deformed until it bounces. So we have it right there. We know that we've already eliminated these two. So the choices are 2 and 3. And we figure that out because scientific principles 2 and 4 help us figure that out. But we didn't know which one. It was either 2 or 3. But any deformed rigid object has elastic energy. This tells us what it is. Because this is still in the air, it has no EE. So this one also eliminates those two. So it's got to be number 2. Got to be number 2. Now, if we quickly go through the next one, an object's elastic energy increases as its deformation and or its rigidity increases. That's true, but it doesn't matter because 3 is in the air. It doesn't have any EE. So that's a mute issue. Energy can be transferred between systems. That's true, but yet that does not help us at all with figuring out which one of these it is, which we already know. It's number 2. And then 9, energy cannot be created nor destroyed. That's true, but that doesn't help us at all figure out which one of these is. So all the scientific principles are true, but 2, 4, and 6 are the ones that narrow it down to number 2. So when we look at our evidence is probably the thing you should attack next. It's the thing you should write next. And sometimes you can get away with writing your claim before looking at your evidence, but I always suggest looking at the evidence to see if your claim is supported. Now, your evidence should be sufficient, it should be appropriate, and this is the biggie, qualitative and quantitative. So you have to have numbers when it's relevant. And you have to also have a description and qualitative data. And this is one of those mistakes a lot of people will make, is they won't have quantitative data. And in order to be proficient for evidence, you have to do all those things. You have to have the quantitative evidence if it's necessary. So let's take a look at what we have here. What is our evidence? What evidence can we use to support the idea that it's number 2? So we think it's number 2 because of scientific principles 2, 4, and 6. So GE is going up. How do we know that? So one piece of evidence is it could be that KE is going up and GE is going down because as the ball is falling, it's gaining speed and it's losing elevation. Or maybe you word it like this, under evidence. Kinetic energy is increasing because as the ball drops, it's gaining speed. And GE is decreasing because as the ball gets closer to the ground, it's losing elevation. So those are 2, and you can write those as 2 separate sentences, 1 sentence, 2 put bullets in front of them, whatever you want. But that's definitely evidence. But that's not all the evidence that we have. Remember, we have to distinguish why doesn't it have elastic energy. So another piece of evidence might be the ball has not yet hit the ground, So there is no EE. So there's three pieces of evidence that support why this is the answer. Any questions with that? Well, kind of a rhetorical question because you can't answer any question, or you can't ask questions watching a video. But those are really only the three pieces of evidence you need. That the KE is decreasing because as the tennis ball is dropping, it is gaining speed. Next piece of evidence, as the ball is dropping, it's losing elevation, so it is losing gravitational energy. And the third piece of evidence, because there is no deformation, there is no elastic energy. If you have those three pieces of evidence, you will have a proficient piece of evidence. So when we make the claim now, remember your claim has to be thorough. It can't be, well, I think the answer is number 2. I'm guessing the answer is number 2. It's got to be number 2. So here's how you might write that. It's got to be a little bit more specific than that. So which energy conversion diagrams on the left, numbers 1 through 4, is the best example of a tennis ball at position 3? So you want to include this in your claim. So if it is indeed number 2, you might write the energy conversion diagram number 2 is the best example of a tennis ball at position 3. Drop mic. That's all you need. So use the question to help guide your answer. Which energy conversion diagram? The energy conversion diagram number 2 is the best example of a tennis ball at position 3. That's all you need. Now, if you want to get a little bit more specific, you can say the energy conversion diagram number 2 is the best example of a tennis ball at position 3 when not factoring in thermal energy. Now, it should all be one sentence. It's just one sentence. That's all you need for the claim. So the reasoning is the hardest part. It ties everything together. And when we look at the rubric, and this is the rubric I use to grade it, first of all, we talked about there's being 3 scientific principles. You need to use all 3 if you want an advanced score. Now, can you get a proficient if you don't use all 3? Yeah, if you have 2 out of the 3, I'm probably going to give you that proficient. But ideally, if you're watching this video, you give me all 3. Why not go for the advanced score? Plus, other things could go wrong, so this could help offset those other things that might go wrong. So, we already talked about the scientific principles. This is where the scientific principles take place in the reasoning. It's so interesting that so many people will include the scientific principles in the evidence, even though if you look at the posters on the side of the room, if you look at the CER writing guides, none of them tell you to put the scientific principles here, but a lot of people do it. Not needed. So when we look at the reasoning, I'm looking for 1, can you restate the claim? So go back up, copy and paste your claim into this section. And what was your claim again? Energy conversion diagram number 2 is the best example of a tennis ball at position 3. That's all you need. Now, you need to have your scientific principles. And the key is, how do the scientific principles link evidence to the claim? So when we look at that, so you've already typed in your claim or you copied and pasted your claim in. So let's look at how we can include the scientific principles in here. So which one do you want to do first? Let's just start in order with number 2. So you might say, scientific principle number 2 says an object's kinetic energy increases as its speed and/or its mass increases. So copy and paste that into yours. Now you have to do the why. Why? So you wrote scientific principle number 2 says that an object's kinetic energy increases as its speed and/or its mass increases. The tennis ball at position 3 is gaining speed as it's dropped, so its speed is increasing. which means its kinetic energy is increasing. So now I just explained why this connects this to your best answer of this. So again, I just explained how this connects these two together, that, yeah, this is my claim that is energy conversion diagram number 2 is the best example for this. Now, so put a period at the end of the sentence. Now, you need to include at least one more scientific principle. How about this one? Scientific principle number 4 says that, or states that, an object's gravitational energy increases as its elevation and or its mass increases. Now, here it says increases, but you might be thinking, well, it's decreasing. The opposite is also true. So you might want to state that. So as the tennis ball at position 3 loses elevation, or you might say as it gets lower to the ground, it is losing GE because it's losing elevation. Again, that tells us, yep, this is true. So we just use scientific principle number 4 to prove this true. We use scientific principle number 2 to prove this true. Now we have to figure out, okay, why is it not EE? And that goes to scientific principle number 6. So go ahead and write in your paper, scientific principle number 6 states that any deformed rigid object has elastic energy if it can return to its original shape. Then you want to add, because the tennis ball at position 3 has not yet hit the ground, it is not deformed, so it has no elastic energy. So if you missed that, rewind the video, listen to it again, type it out. And then the last thing you need to have is you need to have your conclusionary statement. So once we got done talking about how 2, 4, and 6 are relevant, and one sentence is all you need. Therefore, all this evidence proves that the energy conversion number 2 is the best example of a tennis ball at position 3. You're done. So it does take a lot of thinking. It does take a lot of work, but yet hopefully you've seen through sixth grade and 7th grade and 8th grade that there's a rhythm to it, that there's a pattern. And once you figure out that pattern, especially for the reasoning, it's this, CER start to become pretty easy for you. So I hope this CER writing guide helped. If you're still confused about stuff and you're still looking to retake the CER to make corrections, make sure you see me before the deadline. Thanks. Bye.